Hello dear students, welcome back to our 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to cover the most important topic of some basic concepts of chemistry, that is mole concept, percentage composition and stoichiometry. Okay, so you can join our WhatsApp channel, link is there in the description section. So this will help you to get access to our PDF notes, mock test and solutions. Okay, so yes, now let's get started with so I have already explained you this one, how are we going to complete this chapter. So today we are in part 3, okay, and here today we are going to discuss about mole concept, percentage composition and stoichiometry. Okay, stoichiometry is very important. Next weightage of this chapter, you can expect 0 to 1 questions every year. Okay, now coming to here, in today first we will discuss about mole concept. Okay, first we'll talk about mole concept, and after that in percentage composition we'll talk about mass percent and empirical and molecular formula. Then in stoichiometry we will discuss about limiting reagents and the concentration terms. Okay, so yes, now let us start with the first topic, that is mole concept. Okay, this is very important and it will be used in almost every type of calculations. You need to know how to calculate mole concept. Okay, so now let us understand what is mole concept. So now see, mole, okay, mole is nothing but unit of amount of substance. Okay, means see, suppose we are measuring time. For time we have quantities like seconds, hours or minutes, like that. When I want to talk about the amount of substance present somewhere, okay, how much sodium atom is present, or when I want to talk the amount of substance present, we use the unit of that is your mole. Okay, so mole is what? Unit of amount of substance. Now how much is 1 mole? So you need to remember that like we have 1 century. 1 century means always it is a fixed number, that is 100. 1 dozen, that is also a fixed number, that is your 12. Similarly 1 mole is also a fixed number. What is its value? Now 1 mole, okay, is nothing but a specific number, which value, that value is called as Avogadro number and it is denoted as Na. Okay, now what is this called as? Avogadro number. Okay, now what is this value of Na? That is 6.022 into 10 to the power of 23. Okay, 0.22, 0.23 is fine. So that is the value of 1 mole. Okay, now question arises, the meaning. Suppose I say that 1 mole of pencils are there. That means I want to say that 6.022 into 10 to the power of 23 pencils are there. Okay, suppose I say 1 mole of eggs are there. That means 6.022 into 10 to the power of 23 eggs are there. Understood this one? Clear? I hope everybody is clear what is 1 mole. 1 mole is a unit to talk about the amount of substance. And when I say 1 dozen egg, we immediately think, okay, it is 12 eggs, right? If I say 1 mole eggs, that means you need to think that there is 6.022 into 10 to the power of 23 number of eggs. Clear this one? Okay. Now coming to mass. Okay, what is the mass of 1 mole of any substance? Okay, mass of mole of any substance. Now we do not have fixed mass of 1 dozen of egg, right? It may vary slightly, but we have fixed mass of 1 mole of any substance. 1 mass of any mole of the substance will be equal to the molar mass of the substance. Okay, mass of 1 mole of anything will be equal to its molar mass. Okay, now we will discuss in detail. Have little patience and listen here. Now see, suppose I took 1 mole of copper. Okay, I took here 1 mole of copper. Okay, now copper is, sorry, this is 1 mole of carbon. Sorry, once again, yeah, Yeah, suppose I took here 1 mole of carbon. Okay, 1 mole of carbon means how many carbon atoms are there? 6.022 into 10 to the power of 23 carbon atoms are present here. Now what will be the mass of this one? The mass of this one will be its molar mass, that is 12 gram. Okay, so its mass is 12 gram. Okay, its mass is 12 gram. I have taken 1 mole of carbon. Okay, how many particles, how many carbon atoms are there? Because it is 1 mole, it will have Avogadro's number of atoms, right? Next, what is the mass of that 1 mole of carbon? That will be its molecular mass, that is 12 gram. Now if I say I will take 1 mole of copper, here I have taken 1 mole of copper, that means 6.022 into 10 to the power of 23 copper atoms are there. But what is the mass of this one? The mass of this one is 63.5 grams. Getting? So I can say here, like, see, we can understand it in this way. So I will explain this one. So what I am saying is, suppose I am having 1 mole of carbon. Okay, how many atoms are present here? Here the number of atoms, okay, number of atoms is equal to the Avogadro. So how many carbon atoms will be present? 6.022 into 10 to the power of 23 carbon atoms will be present. Now what is the mass of this one? Like if you take this 6.022 into 10 to the power of 23 carbon atoms you take and weigh and you measure that, then the weight of that will come, or the mass will be around 12 grams. Okay. Now similarly, if I take 1 mole of copper, okay, the number of particles, because it is 1 mole, every 1 mole of any substance contains the same number of particles, that is Avogadro number. So it will also have Avogadro number of particles. Now what will be the mass of this much? Like if you take that 6.022 into 10 to the power of 23 atoms of copper and measure it, the mass will be its molar mass, that is 63.5 gram. Clear? So I hope that is clear now. What is 1 mole? So two things you need to remember here. 1 mole of anything, 1 mole of pen, pencil, copper, carbon, oxygen, nitrogen, hydrogen, sodium, anything. 1 mole of anything is equal to 6.022 into 10 to the power of 23 atoms. Okay. Next thing you need to know is 1 mole of anything, the mass of that 1 mole will be equal to the molar mass of that particular compound. Clear? Okay, now we will talk about this table. This is again very, very important. Now see, amount of substance, okay, amount of substance we can represent in 3 ways. One is mass, okay, one is number of particles, okay, and next one is your moles. Okay, we can represent it in 3 ways. Mass, suppose I suppose here some amount of suppose here some sodium atoms are kept. Okay, it is filled with sodium atoms. Now I can tell that what is the mass. I can say, okay, this sodium atom's mass is this much. That is one way how I can tell. Second way I can tell, I will count the number of atoms and I'll tell, okay, these many sodium atoms are present. Or I can tell, okay, these many moles of sodium atoms are present. Okay, so you can represent them in 3 ways. Okay, mass, moles and number of particles. Now we can, if we know, okay, so I told you we can represent it in 3 types, that is mass, number of particles, okay, and moles. Okay, what is this? We can represent amount of substance in this way, right? Now if we see that mass, number of particles and moles, so how can, suppose if I know how much mass is there, I can find these 2 quantities as well. So if you know any one of this, you can find out the other 2. So what is the point here? If you know any one of this, then you can find other 2. Okay, Now how to do this? There is a trick or there is a formula that we need to know. Clear? So now I'll make a what else? I'll make a table and we'll understand in that way. Okay, this also you can see, we'll come back to it. So now first of all, at the center you should keep moles. Okay, then I can say for example, okay, let me erase it and we'll do it clearly. Okay, so now here suppose we have moles, okay, and we have number of particles, okay, and we have mass. Okay, now see, I'll tell you a pathway and you need to follow that path clearly. Suppose you know what is the amount of moles are present. Okay, you know something about sodium, how many moles are present. You want to know its mass. Then what you need to do? If you want to calculate from moles to mass, you need to multiply with molecular mass, or I can say molar mass. Okay, if you know moles and you want to calculate mass, then just multiply it with molar mass. Like for example, how can happen? Like example I'll give you. Suppose I'll tell there are 2 moles of water. Okay, I gave you 2 moles of water is there. Find out its mass. Then you know 1 mole or 1 molecular mass of water is how much? 18. So 2 moles will be 36 gram, right? 2 into 18 you are doing. So number of moles into the molecular mass will give you the total mass, right? Next, if you know moles and you want to calculate number of particles, then you need to multiply with Avogadro number, right? Now suppose I tell you there are 2 moles of water here. Okay, calculate the number of particles. Okay, so number of particles will be what? 2 into, or number of molecules of water will be 2 into Avogadro number. Clear? This is done. Now if mass is given and you want to calculate moles, then you need to divide with molar mass. Okay, you know the mass and you want to calculate the number of moles, then you need to divide with the molecular mass. And similarly, if you know the number of particles and you want to calculate moles, then you need to divide with the Avogadro number. Okay, I want every one of you to understand this and remember this. This will be very, very helpful to solve questions. Clear? If moles is given, mass is to be calculated, multiply with molar mass. Mass given, moles to be calculated, divide by molar mass. Moles given, number of particles to be calculated, into Avogadro number. Number of particles given, moles to be calculated, divided by Avogadro number. Now if I want to calculate from here number of particles to mass, then you first number of particles should be converted to moles, then moles should be converted to mass. Okay, so anything given, if this is given, you can calculate these two very easily. If this is given, then you need to follow this path and calculate the other two. Clear? Okay, so now let us do a question here. Okay, in 3 moles of ethane, calculate the following. Okay, we are given with 3 moles of ethane. Okay, now before doing this one, let us understand what is this, what is present in 1 mole of ethane. This is very, very important. In 1 mole of ethane, okay, we have 2 moles of carbon, okay, and we have 6 moles of hydrogen. Got it? In 1 mole of methane, in 1 mole of ethane, we have 2 moles of carbon and 6 moles of hydrogen. Clear? Now question is asking number of moles of carbon atoms in 3 moles of ethane. So I can say that in 1 mole of ethane, we have 2 moles of carbon, right? Then in 3 moles of ethane, how many moles of carbon will be there? 6 moles of carbon will be there, right? So the answer here will be 6. Next, number of moles of hydrogen atoms. Number of moles of hydrogen atoms. So if you want to calculate number of moles of hydrogen, so I can say that in 1 mole of ethane, right, we have 6 moles of hydrogen, right? 6 moles of hydrogen are there. Then in 3 moles of ethane, C2H6, 3 moles of ethane, we will have 18 moles of hydrogen, right? That means here answer will be 18 moles. Clear? Next, number of molecules of ethane, total number of molecules of ethane. Now you see, I told you in 1 mole of ethane, okay, there will be how many particles? Every time 1 mole means Avogadro number, okay. So I can say that in 1 mole of ethane there will be 6.022 into 10 to the power of 23 ethane molecules, okay. Then in 3 mole how much it will be? So in 1 mole it is this much, so in 3 mole it will be 3 into 6 into 10 to the power of 23. For easy calculation I am just considering at 6, then I can say 18 into 10 to the power of 23, okay, or you can write 1.8 into 10 to the power of 24, okay. So what will be the answer here? 18 into 10 to the power of 23. Clear? I hope all of you are getting this one. Okay, now let us see the next question. Okay, if 3.01 into 10 to the power of 20 molecules are removed from 98 milligram of H2SO4, then the number of moles of H2SO4 left are, okay. So this question was asked in 2017, okay. Now let us try to solve this question. See, you have how much? 98 milligram of H2SO4. So what I can say, total how much I have? Total is 98 milligram of H2SO4, okay. This is given in terms of mass, but the amount removed, that is given in terms of number of molecules, right? It is given in terms of molecules, it is given in terms of mass. So we can convert this one to number of molecules, okay. So what I'll do, I'll say that total 98 milligram of H2SO4 is there, okay. Then what is the number of moles of H2SO4? If you remember the table, I'll do, if I have mass here, okay, I have moles here, and I have number of particles here, and I'm just writing number of atoms, okay. Then if you remember moles to mass, if I want to convert moles to mass into molecular mass, mass to moles divided by molecular mass, right, moles to number of particles into Avogadro number, and number of particles to moles divided by Avogadro number. Clear? Now if you see that number of moles of mass is given and I want to calculate number of moles, right? Mass is given to me how much? 98 milligram, and I want to calculate number of moles. Then what I should do from here to here, if I want to go, I will divide by the molar mass, right? So to divide by the molar mass, so if you calculate H2SO4 molar mass will be 98 grams, okay. So what I can do, 98 milligram, I'll convert it into grams because units should be same, okay. This is the mass that is given, divided by the molar mass is 98 grams. So how much I'll get? 10 to the power of minus 3 moles, okay. I got that. So I can say now that how much H2SO4 I have? 98 milligrams or 10 to the power of minus 3 moles. Now let us calculate in terms of atoms, number of H2SO4 molecules, okay. So if I want to calculate number of moles I know, and I want to calculate the number of particles, then what I need to do? Into Avogadro number, So what I'll do? So I have number of moles as 10 to the power of minus 3, and Avogadro number I'll write 6 into 10 to the power of 23. So that will give me 6 into 10 to the power of 20, okay. Clear? So total how many number of moles here I have? 6 into 10 to the power of 20 H2SO4 molecules are there, okay. Now what we need to do? Now the question, so I can say that total how much I have? 98 milligram or 10 to the power of minus 3 moles or 6 into 10 to the power of 20 H2SO4 molecules are there, okay. So now what we need to do? We need to subtract this one, right? So 1 second, okay, 10 to the power of minus 3 we multiplied here, so we will get, yeah, 6 into 10 to the power of 20, right? So now what we should do, then the number of moles of H2SO4 is removed, okay. Question is asking you to calculate the number of moles of H2SO4 removed, okay. First let us calculate number of then the number of moles of H2SO4 left. Okay, first let us see how much number of H2SO4 removed. Removed is how much? 3 into 10 to the power of 20. Okay, I'm just taking 3 for easy calculation. Then how many number of H2SO4 molecules left is, so 6 was the total, 3 is removed, so I am again left with 3 into 10 to the power of 20, right? Now what to see? Now the question, so the number of H2SO4 molecules left is 3 into 10 to the power of 20. But the question is asking to calculate moles of H2SO4 left. We have now what? Number of particles left we have 3 into 10 to the power of 20. But we need to calculate the number of moles. That means what? You need to divide with Avogadro number. So I can say that here moles of H2SO4 left, okay, is equal to 3 into 10 to the power 20 by 6 into 10 to the power of 23, right? So now if I do this, I'll get what? 0.5 into 10 to the power of minus 3. Okay, so correct answer here will be option number A. Okay, fine. This was a very important question. All your conversion concept would have been cleared. Okay, let us see the next question. Calculate the number of atoms in each of the following. Okay, so again I'll draw that. If you have moles, okay, and you need to calculate mass, then what you need to do? Into molar mass. If you have mass and you want to calculate moles, then divide by molar mass. Okay, similarly for number of particles, okay, if you have moles, then you multiply with Avogadro number, and this side you divide by Avogadro number. Okay, now let us try this question. 52 moles of argon is there. You need to calculate the number of atoms. You need to calculate the number of particles. And what is given to you? Moles. 52 moles are given. So moles to particles, simply what you need to do? Multiply with the Avogadro number. So calculation part you can do 52 into Avogadro number, 6 into 10 to the power of 23. Now let us see the second one, that is 52U. Okay, now 52U, U stands for atomic mass of unit, okay, or I can say the mass of one atom is like atomic mass unit. So there is the 52U is what I can say, the mass of the atoms, some number of atoms were there and its total mass was 52U. Okay, now if you know mass of one helium atom is 4U. Okay, now I can say the total mass is 52U. Okay, so now number of atoms will be equal to 13 atoms. Okay, so that will be equal to 13. Next, 52 gram is given. Okay, now 52 gram of helium, so this mass is what? 52 gram. Okay, now if I divide with the molar mass, okay, here there is atomic mass, here it is molar mass. Okay, so if I divide here 52 gram divided by 4 gram, I'll get 13 moles. Okay, understood? 13 moles I am getting. Now again if you want to convert it in number of particles, 13 into 6 into 10 to the power of 23. Okay, so these two options are very important to understand here. 52U means it is the masses of the atom. So if you just divide with the atom of one mass of one atom, you will get the number of helium atoms present. But here when you divide it with 4 gram, you are taking the molar mass, so it will give you the number of moles. Okay, fine. Now let us see what is mass percent. So mass percent of an element, okay, so the mass percent of an element is calculated like this: mass of that element in the compound divided by the molar mass of the compound into 100. Okay, we'll understand it with an example. So calculate the mass percentage of different elements present in sodium sulfate. Okay, let us first solve an example here. Suppose we have calcium carbonate. Okay, you want to calculate the mass percentage of each element. Okay, so I can say what is the mass percent of calcium. Okay, so if you see what is the mass of calcium here, calcium is 40, okay, carbon is 12, oxygen is 48, right, each oxygen is 16, there are 3 oxygens, so total is 48. Now what is the total mass of the compound? Total mass, if you add all this, we will get 100, right? Now what is the mass percentage of calcium? You will get 40, okay, the given mass divided by the total mass, that is 100 into 100, okay, so we will get 40%. Similarly, if I see mass percent of carbon, okay, then how much it will be? Carbon is 12 gram divided by the total mass is 100 into 100, okay, so that will be 12%. Next, mass percentage of oxygen, right? So oxygen is 48, okay, divided by 100 into 100, and that will be again 48%. Clear? So that is how you can calculate mass percentage. Let us try this question. You have to calculate the mass percent of different elements present in sodium sulfate, okay. So what is the mass of sodium? Each sodium is 23, there are 2 sodium, so it is 46, okay. What is the mass of sulfur? 32, okay. What is the mass of oxygen? Okay, so oxygen is 16, each oxygen is 16, 4 oxygens are there, so it will be 16 into 4, and that is equal to 64, okay. So now if I add these all, okay, so how much I'll get? Total mass is what? So 6, 7, 8, 8 plus 4 is 12, so I can carry 1 here, then 6 plus 1, 7, plus 3, 10, 10 plus 4, 14. Okay, so I got total mass as 142. Now if I want to calculate the percentage of sodium, then what will be there? What is the mass of sodium? 46. Total mass is 142. So 46 by 142 into 100. Okay. Next, mass of sulfur. So that is, mass of sulfur is 32 divided by 142 into 100. Now next is mass percentage of oxygen. So I have 64 divided by 142 into 100. Okay. Now if you solve this, we will be getting these answers. You can check the calculation. Here we will be getting 32.39. Here you will be getting 22.5, and here you will be getting 45%. Okay. Fine. Now let us talk about what is empirical formula and molecular formula. Okay, we will go to the definitions later. Now let us understand with a simple example. So all of you know, all of you might have heard about glucose, right? What is the molecular formula of glucose? C6H12O6, right? Now what can I do is, I can see a common term between all 3 numbers, right? The common term here is 2. So can I cancel it with 2? So I will get C3, sorry, the common term is 3, sorry. Okay, one second. We will like take the highest common factor and just divide it. So we will get C, I can cancel it with 6, and then 2, then O, right? 6, I just cancelled it. 6 ones are 6 twos are 6 ones. So this one, this formula is called the actual formula or the molecular formula. Now this represents what? This represents the simplest ratio in which the atoms are present. The atoms are present in the ratio of 1:2:1. So this ratio is nothing but your empirical formula. Clear? Empirical formula represents the smallest ratio of atoms present in a compound. Molecular formula is the actual formula of the compound. Okay, and here I want to tell you a formula, that is molecular formula, okay, is equal to empirical formula into N. Okay, now what is this N? So just we'll discuss this. So N is equal to molecular mass. N is equal to molecular mass divided by empirical formula mass. Okay, we'll discuss this formulas questions, it will be more clear. But now first understand what is the definition of empirical formula and the molecular formula. Okay, fine. Now this is a question to calculate how to find the empirical formula. Okay, so now you see, A pure compound contains 2.4 gram of carbon. Okay, fine. Next, 1.2 into 10 to the power of 23 atoms of hydrogen. Okay, that is also fine. Next, 0.2 moles of oxygen. Right? What is the empirical formula here? So to calculate empirical formula, what you need, the simplest ratio of the moles of atoms present in a compound, right? So first let us see what is the number of moles of carbon here. Given mass by molar mass, so 2.4 by 24, that is 0.1. So what I want to say, number of moles is nothing but given mass, okay, divided by molar mass. So that is what we are doing to convert it, right? Okay. Now here number of particles are given. So if you remember that table, let me draw it here in a, like if we have moles, okay, to go to number of particles, and this side if I have mass, so I am writing it again and again so that you will remember. Okay, this is very, very important. Okay, mass. So moles to mass, if you go multiply with molar mass, mass to moles you need to divide by molar mass. Moles to particles into Avogadro number, mass to moles divided by Avogadro number. Now if you see for carbon, mass was given, I wanted to calculate moles, so I divided with the molar mass, and carbon mass is 12. Okay, carbon mass is 12, right? Yes, so it will get 0.2. Fine. Next, if you see here, what I'll get, number of particles of this one is given. Number of particles is how much? 1.2 into 10 to the power of 23. So what I can do, number of moles, if I want to find number of moles, I'll divide with Avogadro number. So 1.2 into 10 to the power of 23 divided by 6 into 10 to the power of 23, and that will also give me 0.2. So what is the ratio of number of moles of carbon, number of moles of hydrogen, and number of moles of oxygen? 0.2, 0.2 and 0.2, that is 1:1:1. So what will be the empirical formula? C, H and O. So option number D will be the correct answer. Okay, this was asked in 2021. Fine. Now let us see the another question. The molecular formula of a compound is C6H12O6. What is the empirical formula of the compound? So this is very easy. We have just done. You need to cancel and like C6H12O6. What is the ratio? C6 then 12 and then 6, and we can cancel it to like this, right? So CH2O, option number D. Okay. Next, determine the molecular formula of an oxide of iron in which the mass percentage of iron and oxygen are 69.9 and 30.1 respectively. Okay, so these type of questions are important. Here we need to do learn the calculation and calculate the empirical formula. Now what is the rule here? First you see, then we'll go to the question. First, whenever percentage is given and empirical formula is asked, you have to follow this. Okay, first you have to make a table. In the first column, element name you need to write. Okay, second column, one second. So second column will be the percentage that is given. Third column you need to find out number of moles. Okay, then here you want to find the simple ratio. Okay, and next one is whole number ratio. Okay, now see, first elements will be given to you in the question, percentage will be given to you in the question. Number of moles, what will you do? Whatever percentage is given divided by the molar mass of that particular compound or element, that will give you the number of moles. For simplest ratio, what you need to do? You need to divide the smallest number to all numbers. Okay, I'll explain, do not worry. Then whole number ratio. Okay, now let us solve this question and see. So I have solved this question for you. So now what is element here? Fe is 69.9% and oxygen is 30.1%, right? So I want to calculate number of moles. So how will I calculate number of moles of Fe? given mass by molar mass. So 69.9 divided by 56, and that will give me 1.24. Clear? Next, number of moles of oxygen, 30.1 divided by 16, and that will give me 1.88. Clear? Now simple ratio, how to calculate? For simple ratio, you need to divide the smallest out of these two to all the numbers. Here 1.24 is smallest, so 1.24 you need to divide with this number and also with this number. So 1.24 here by 1.24, that will give me 1, and 1.88 divided by 1.24, that will give me 1.5. okay. So now if this is coming in some whole ratio, okay, like suppose here also you are getting 2 or 1, then directly you can consider that for empirical formula. But since we are not getting a whole number here, you need to multiply with the smallest number here so that we can get the whole number. Now you see, if I multiply here 2, okay, into 2 and into 2, then I will get what? This one will become 2 and this one will become 3. So I got a whole number here. So what is the ratio? We got Fe2O3. That is the empirical formula. Clear? Okay. Now, one second. Determine the molecular formula on oxide in which the mass. Okay, so this was your empirical formula. Okay. Next, let us do the question. A compound consists of 52.17% of carbon, 13.04% of hydrogen and 34.78% of oxygen. Find the molecular formula if the given formula, if the molecular weight of the compound is 46 gram. Okay, so now let us first solve this. So first of all, here you need to calculate molecular formula, okay, but for knowing molecular formula, what is the formula I told you? Molecular formula is equal to empirical formula into N. And how to find N? N is your molecular mass, okay, N is molecular mass divided by empirical formula mass, okay, understood? So let us try this question now. First thing is to calculate empirical formula, how we have just discussed in the previous question. So if you see, we have what we have got here, we have got carbon, hydrogen and oxygen. Carbon percentage is 52.17, hydrogen is 13.04 and oxygen is 34.78. Now to calculate number of moles, you need to divide this by 12, this divide by 1 and this by 16. So if I divide these all things, I will get 4.34, 13.04 and 2.17. Next, what I need to do? I need to divide the smallest of all to all these numbers, right? So if I divide this, I will get 1 here, 6 here and 2 here. So what is my empirical formula here? So the empirical formula is, the empirical formula is C2H6 and O. Okay, that is the empirical formula. Next, but the question is asking me to find the molecular formula. So for empirical formula, first I need to calculate this N value. For N value, I need molecular mass and empirical formula mass. So let us calculate empirical formula mass. So that is what you just need to calculate the mass here. So we have 12 into 2, okay, plus, one second. So next we have here plus 6 into 1 plus 16, okay. So that will give us what? 12 2s are 24, 24 plus 6, 30, 30 plus 16 is 46, okay. Now let us calculate the value of N. N is what? Molecular mass by empirical formula mass. So the molecular mass is 46 and the empirical formula mass is 46. So 46 by 46, that is equal to 1. Now I need to find the molecular formula. So molecular formula is empirical formula, that is C2H6O into 1. When you are multiplying this, you need to multiply with these numbers, okay. So I will get C2H6 and O, okay. So you can see that one here, C2H6 and O. So option number A is the correct answer, okay. Fine. So now let us go to stoichiometry, which is very, very important. Questions on the KCET will be asked from this particular section especially. Now what do you mean by stoichiometry? So now you see, when you write a reaction, suppose stoichiometry is the calculation of how much product will form if you know how many reactants are there or how many reactants are needed to produce a certain amount of product, okay, and for this we always need the balanced equation, okay. So now suppose this equation is there with you, okay, CH4 plus 2O2 gives CO2 plus H2. Let us first check, is it balanced? Carbon carbon, yes, 4 hydrogen, yes, and then we have 4 oxygen as well. So what does this particular reaction gives you information? That is very, very important. So here I can say one thing, that 1 mole of methane reacts with 2 moles of oxygens to give 1 mole of carbon dioxide plus 2 moles of water. We can say in that way. Or if I want to talk in terms of masses, right? So we know 1 mole of CH4 is what? 12 plus 4, 16. So I can say 16 gram of CH4, okay, reacts with, here oxygen, we have 32 to 64 gram of oxygen, okay, to give 1 mole of carbon dioxide, or I can say 44 gram of CO2, and we have 36 gram of water. So I just added, multiply this one. So we have 2 moles of water here, right? 2 times of H2O. So each water is 18, so 2 into 18 is 36. So this is the 2 important things you should understand from a balanced chemical reaction. What does it tell about the amount of reactants and about the masses of the reactants and products? Okay, we'll do questions and it will be more clear. Fine. Now let us see a question here. It's a reaction given to you, okay, and the question is asked, how many grams of HCl react with 5 gram of manganese dioxide? Okay, the question is asking you how many grams of HCl will react with 5 grams of MnO2. Okay, so let us solve this question and see. So what is according to this balanced equation? I can say that 4 moles of HCl reacts with 1 mole of MnO2. Okay, if I want to talk in terms of one second. So here also one thing you should remember, one trick, or I can say which I feel easy. I won't say this is a trick, but the one method which I follow is here, quantity asked should be in right, should be on right side of statement or equation. Okay, now I'll tell you what. See here, the question is asking about what? How many grams of HCl. So question is asked about HCl, and it is given, the question has given you about MnO2. So whichever quantity is asked, I want to keep that on the right hand side. Okay, so I can say now that 1 mole of MnO2, okay, reacts with 4 moles of HCl. Okay, now I can convert it into mass also, that will be more easy because question is given in terms of mass. Okay, so 1 mole of MnO2. So if you know manganese mass is 55, okay, oxygen is 32. So I will get 87, I can say. So I can say that 87 gram of MnO2, okay, reacts with 4 into, this mass is what? 35 plus 1, in 35.5 is chlorine and hydrogen is 1. So 36.5 gram of HCl. Okay, now 1 gram of MnO2 will react with how much? Okay, 1 mole of MnO2. So 1 mole of MnO2 will react with 4 into 36.5 divided by 87 grams of HCl. Okay, now question is asking about what? 5 gram of manganese dioxide. So 5 gram of MnO2, right, will react with 4 into 36.5 by 87 into 5 grams. Just unitary method you need to solve it. So once you solve this, you will be getting around 8.4. So I can say that 5 gram of MnO2 reacts with 8.4 gram of HCl. Okay. Okay, let us see the next question, something about limiting reagent. What is limiting reagent? Now see, limiting reagent, suppose A and B are reacting. Okay, now suppose in a reaction you have taken 2 moles, or I can write like A plus 2B I am writing. Okay, so suppose in a reaction you have taken 2 moles of A, okay, and you have taken like 8 moles of B. Okay, now according to the reaction, according to the balanced equation, okay, according to the balanced equation, what we can say, 1 mole of A is reacting with 2 moles of B, then 2 moles of A will react with 4 moles of B, right? So see, at initially, okay, when you started with the reaction, you had 2 moles of A and 8 moles of B. Now the reaction is completed. T, I can say after completion. So 1 mole of A is reacting with 2 moles, then 2 moles of A would have reacted with 4 moles of B. So all the A would have been completed, but from B only 4 moles have been used. What is left? Still 4 moles of B is left, right? So this reactant which is left in excess or which is not completed in the reaction, that is called as the excess reactant. Okay, and the one which is consumed completely in the reaction is called as the limiting reactant or limiting reagent. Okay, now what is the role of this limiting reagent? Why do we need to calculate or why do we need to find out which is the limiting reactant? So the product formed depends on the limiting reactant. Okay, I'll do a question and it will be understood at that time well. So how much C will form, okay, will depend on the limiting reactant, that is A. Okay, so now let us solve a question here and it will be more clear. Okay, so now the question is like this: 1 gram of magnesium is burnt with 0.28 gram of oxygen in a closed vessel. Which reactant is left in excess and how much? Okay, let us find out this first. So this is a previous year question in 2018. Okay, so first thing always you need to do is you write a balanced reaction. So what is the balanced reaction? I can write 2 mg plus O2 gives 2 mg. Okay, now what does this statement says you? What information it gives you? I can say that 1 mole, okay, of oxygen reacts with 2 moles of magnesium, right? Now 1 mole of oxygen is how much? I can say 32 grams reacts with 2 moles of magnesium. Each magnesium is how much gram? Each magnesium is 24 gram. So 2 moles will be 48 grams, right? So now 1 gram of oxygen will react with 48 by 32 gram of magnesium. Okay, so now if I solve it, we'll get like okay, we'll keep it like this. Now in the question, how much gram of oxygen is there? 0.28. 0.28 gram of oxygen will react with how much? So I can write 48 by 32 into 0.28. So let us try to solve this. So we have like 4 12s are 4 8s are, right? Then we can calculate again 4 2s are 4 3s are. Then I can do here 2 1 4s are. So I'll get 3 4s are 12, 3 1s are 3, 0.42 grams of magnesium, right? So 0.28 gram of oxygen requires only 0.42 gram of magnesium, right? But in the question, how much gram of magnesium is given to you? So total magnesium present is how much? 1 gram. Now magnesium used in reaction is how much? 0.42. Okay, so magnesium left after reaction is 1 minus 0.42. Okay, so we will get 0.58. Okay, and which is left? Magnesium is left, so definitely magnesium is the excess reactant. So that is why option number B is the correct answer here. Okay. Let us see one more question here. 0.54 gram of dihydrogen is made to react with 7.1 gram of dichlorine to form hydrogen chloride. Okay, so reaction is between what? Dihydrogen and dichlorine to form HCl. Okay, the volume of hydrogen chloride formed, the volume you need to calculate of hydrogen chloride formed at 273 Kelvin and 1 bar pressure is. Okay, so to calculate the amount of volume, we need to know one formula which we will discuss now, that 1 mole, okay, 1 mole of gas at 273 Kelvin and 1 atm pressure occupies how much volume? 22.7 liter. Okay, you need to remember this value. Okay, 1 mole of any gas at 273 Kelvin and 1 atm pressure occupies 22.7 liter. Okay, now let us go back to the question. So the question is saying that how much dihydrogen is there? 0.4 grams. Okay, and dichlorine is 7.1 grams. Okay, and that's all. Fine. So see, if I know how many moles of HCl is produced, okay, if I can calculate how many moles of HCl will be produced, then easily I can calculate the volume of HCl produced, right? And I told you the product formed depends on what? Depends on the limiting reagent. So first of all, we need to find the limiting reagent here. Okay, so see here. So first we can calculate the number of moles of H2 given mass by molar mass. So 0.4 by 2. So I'll calculate here 0.4 by 2, that is 0.2. Okay, and what is the number of moles of chlorine? Number of moles of chlorine is given mass by molar mass, so that is 0.1, right? So what I can say in this reaction, okay, in this reaction of H2 plus Cl2 gives 2HCl. What are the amounts we are having? We are having 0.2 moles of H2, 0.1 moles of Cl2. Now with this reaction, what you can say? 1 mole of H2 is reacting with 1 mole of Cl2. So I can say 0.1 mole of Cl2 will react with 0.1 mole of H2. So after the reaction is happening, this one will become 0. Okay, after completion of reaction. Okay, after complete reaction, this one will become 0. So 0.1 will use only 0.1 and 0.1 will be left, right? So which is the limiting reagent? The chlorine is the limiting reagent and hydrogen is the excess reagent. Now what I said, what we discussed, that the product formed, okay, that depends on the limiting reagent. So we need to check the stoichiometry here. Now 1 mole of Cl2, let me write here, one second. Okay, so now you can see 1 mole of Cl2 produces how many moles of HCl? 2 moles of HCl. Now how many Cl2 has reacted? 0.1 has reacted. So 0.1 mole of Cl2 will give you 0.2 mole of HCl, right? So now I can say that how many moles of HCl is produced? So moles of HCl is 0.2. Now what is the volume of HCl? That is 0.2 into 22.7. Okay, so now if you solve this, you will get 4.54. Okay, just you can solve, multiply and check. 2 7s are 14, 2 2s are 4, plus 1 5, 2 2s are 4. So you need to put 2 decimal places, so 4.54 liter. Okay, clear? Fine. Next, let us go to the next topic, that is concentration terms. Okay, so concentration terms means what? It is used to tell how much solute is present in a particular solution. Okay, it is used to tell about the amount of solute, okay, amount of solute present in a solution. Okay, so now, there are four concentration terms that we need to study, that is your mass percent, then mole fraction, okay, then molarity and molality. First, coming to mass percent, we have already seen one mass percent, and that is the mass percent of an element in a compound, and this is the mass percent of a solution. So in mass percent, if I want to calculate, the formula is mass of the component in the solution divided by the total mass of the solution into 100. Okay, mass of the component in the solution divided by the total mass of the solution into 100. Okay, now let us see the next one, that is mole fraction. So if you want to calculate mole fraction of a component, the formula here is number of moles of component divided by the total number of components. Okay, we'll do one question here. Now see, calculate the mole fraction of ethylene glycol C2H6O2 in a solution containing 20% of ethylene glycol by mass. Now see, this is very important question here. 20% of ethylene glycol, okay, 20%, that is by mass. What do you mean by this 20% of this one? That means in 100 gram of solution, okay, so I'll draw it in diagram way, that will be more clear. So what is the meaning of this one? See, here the meaning is, if the 100 gram is solution, okay, percentage means it is always 100 gram. So the total solution is 100 gram. 20 gram is what? Ethylene glycol, and 80 gram is water. We knew that 20 gram of ethylene glycol is present and 80 gram of water is present. Now we need to calculate the number of moles, right? So let us first calculate the molar mass of ethylene glycol. Okay, molar mass of ethylene glycol. So it is C2H6O2. So 12 2s are 24, 24 plus 6 is 30, and 30 plus 32 is 62. Okay, so let me check once again. 12 2s are 24 plus 6 30, 30 plus 32 62. Okay, so number of moles of ethylene glycol, I am just writing ET. Given mass, how much is the given mass of ethylene glycol? 20. Molar mass is 62, 20 by 62. Number of moles of water, given mass is how much? 80. Molar mass of water is 80. Now if I want to calculate the mole fraction of ethylene glycol, right? So mole fraction, the symbol is this X type kite, we call it, of ethylene glycol will be number of moles of ethylene glycol divided by number of moles of ethylene glycol plus number of moles of water. Okay, so that will be equal to number of moles of ethylene glycol is 20 by 62, and here again 20 by 62 plus 80 by 18. If you solve this, you will be getting around 0.068. Okay, so you can do the calculation and check. Okay, next concentration term is your molarity, and here molarity is number of moles by volume of the solution in ml into 1000. Number of moles of the solute by volume of the solution in ml in 1000. Okay, now how to calculate number of moles? Given mass by molar mass into 1000 by volume of the solution in ml. Okay, see a question here. Calculate the molarity of a solution containing 5 gram of NaOH in 450 ml of solution. So first molarity formula is what? W2 by M2 into 1000 by volume in ml, right? Now what I can do, given mass, which is the solute here, you can see the solute is NaOH, right? So what is the mass of NaOH? 5 gram. Now let us calculate the molar mass of NaOH. So I have Na, O and H. So this is 23, this is 16, and it is 1. So I'll get here 40 gram. Okay, so 5 by 40 into 1000, okay, by volume is equal to 450. Now if you solve this, you will be getting around 0.278. Now how to write the unit? It is 0.278 to capital M. Okay, the unit for molarity is capital M. Okay, Next term is molality. Here molality formula is moles of the solute by mass of the solvent. This is important. Mass of the solvent in grams into 1000. Okay. So moles of the solute you can write W2 by M2 into 1000 by mass of the solvent in grams. So now let us do this question. Calculate the molality of 2.5 gram of ethanoic acid in 75 gram of benzene. Okay. So molality small m. Okay, it is with small m. So W2 by M2 into 1000, okay, by mass of the solvent, that is W1. Now let us calculate what is the molar mass first. Let us calculate. We have here CH3, then C2O, and so let us write out together. Okay, sorry. So we have here 2 carbons, right? So 2 carbons, then we have 4 hydrogens, and then we have 2 oxygen. Okay, 2 carbon, 4 hydrogen, 2 oxygen. So we will get 12 into 2, 24. Then we have 4 here, and 16 into 2, 32, right? So we will get 60 grams. Okay, so I am doing all the calculations very step by step so that you can understand. So 2.5 gram of ethanoic acid, then molar mass is 60 gram into 1000, right? What is the mass of the solvent? 75 gram. So now if you solve this, you will be getting around 0.556. Small m is the unit. Okay. So yes students, that's all in this lecture. Now we are going to practice some questions. Okay, let us see these questions. Before that, let us discuss this question. This was the homework question that I gave you. A sample of carbon, okay, that contains 70% of carbon 12 and 30% of carbon 14. What do you think is the average atomic mass of this sample? So you can do this calculation very easily. That is 70 into 12, okay, and 30 into 14, okay, divided by 100. So if you solve this, you will be getting around 12. So answer is option number D. Okay. And one more thing also, I'll tell you how easily you can solve it. You can see all the options are near to 14, okay, but carbon 12 is 70%, right? So the average mass will be towards 12. So that is why also you can rank directly. You can mark option number D. Fine. Next, an organic compound contains C 40%, H 13.33%, and 46.67% its empirical formula is. So this question you can try, 2019 question, the table you need to do. So I have drawn here and I can show you. So carbon is 40%, okay. So carbon is 40%, hydrogen 13.3, nitrogen 46.67. Number of moles, this one should be divided by 12, divided by 1 and divided by 14. So we will get these numbers. The smallest one is 3.3. So divide all the numbers with 3.3. So 114. So we will get the formula CH4N. CH4N, option number C. Okay. Next, 0.4 gram of dihydrogen is made to react with 7.1 gram of chlorine to form hydrogen chloride. The volume of hydrogen chloride formed. So this question we have already discussed. Answer here was 4.54 liter. You can check, we have discussed already. Okay, next, the number of oxygen atoms in 4.4 gram of CO2. This is very important question. Okay, 2016, this previous year question it was asked. Number of oxygen atoms in 4.4 gram of CO2. Okay, so what I can say first, let us step by step. Mass of CO2 is how much? 4.4 gram given. Okay, what is the molar mass of CO2? If you just add 12 plus 32, it is 44 gram. Okay, next, number of moles of CO2, given mass by molar mass. So given mass is 4.4, molar mass is 44. I'll get 0.1 mole, right? Now what I can say, if you see now, I can say that in 1 mole of CO2, okay, there is 1 mole of carbon and 2 moles of oxygen. Okay, now if it is 0.1 mole of CO2, okay, if it is 0.1 mole of CO2, then I'll get 0.1 mole of carbon and 0.2 2 mole of oxygen. Okay. So how many moles of oxygen I got? 0.2 moles. Now to calculate it into number of atoms, what I need to do? I need to multiply it with Avogadro number. So 6 into 0.2 into 10 to the power of 23. So 1.2 into 10 to the power of 23. Okay. So that is option number A here. Okay. Very simple question. Sorry. Next. What amount of dioxygen contains 1.8 into 10 to the power of 22 molecules? Okay. What amount of oxygen? So if you see 1 mole of O2 contains 6 into 10 to the power of 23, right, oxygen molecules. Okay, or I can say in the reverse way also, 6 into 10 to the power of 23 oxygen molecules is present in 1 mole of O2, or I can say 6 into 10 to the power of 23 oxygen molecules is present in 32 grams of O2, right. So now if I want to calculate 1 molecule of O2 will be equal to 32 by 6 into 10 to the power of 23. Now how many I want? 1.8 molecules, right. So for that how much mass I needed? So that is 32 by 6 into 10 to the power of 23 into 1.8 into 10 to the power of 22. Okay. So now if I solve this, we'll be getting around 0.3, right. So I can get 3 2s are 6, 3 3s are 9, 9.6 into 10 to the power of minus 1. So I'll get 0.96, right. Once let me check the calculation. So okay, yeah, so 0.96. so option number A will be the correct answer here. Okay. So if you take 0.96 grams, then the weight or the number of atoms present there will be, number of molecules of oxygen present there will be 1.8 into 10 to the power of 22. Okay. Fine. Next question, let us see. 0.3 gram of an organic compound contains carbon, hydrogen and oxygen. On combustion yields 0.44 gram of, okay, 0.44 gram of carbon dioxide and 0.18 gram of H2O. Okay. If 1 mole of the compound weighs 60 gram, then the molecular formula of the compound is, okay. So there was an organic compound, okay. So here the question is like this, there is some organic compound and when it undergo combustion we get carbon dioxide and water, okay, and this organic compound contained what? Carbon, hydrogen and oxygen. Now see, whatever this carbon produced here, okay, carbon dioxide produced here, in that the carbon which is present, that carbon must have come from this organic compound. This oxygen can be from the organic compound as well as from the atmospheric oxygen, but the carbon which is present here has to be from this organic compound. There is no other source of carbon. Similarly, whatever hydrogen is present in this water molecule, whatever amount of hydrogen is present, that much hydrogen must be present in this organic compound, right. So what we can do is, see, carbon dioxide is how much? 0.44 gram and this one is 0.18 gram. So I can say number of moles of carbon dioxide is how much? 0 given mass by molar mass. So I can say 0.01. Okay. Now number of, so I can say that in 1 mole of CO2 I have 1 mole of carbon, right. So in 0.01 mole of carbon dioxide we have 0.01 mole of carbon. Okay. Now talking about water. So number of moles of water is how much? Given mass is 0.18, molar mass is 18, again 0.01. But here in 1 mole of water, okay, we have 2 moles of hydrogen, right. So in 0.01 mole of water we will have 0.02 moles of hydrogen, right. So I got what here? We got the number of moles of carbon in that organic compound is 0.01 and number of moles of hydrogen is 0.02. Okay, fine. Next, what is told is okay. Next, we can calculate then the molecular formula of the compound we need to calculate, and if 1 mole of an compound weighs 60 gram. Okay, so now what do we observe here? In number of moles of carbon and number of moles of hydrogen. Okay, so number of moles of carbon to number of hydrogen is double of this one. Means what I can say in these examples, in the options, the number of moles of carbon, okay, should be like number of moles of hydrogen should be double the number of moles of carbon. The ratio you can see 1:2, right? Now if you see the option, this is not 1:2, eliminate. Here it is 1:2, here also it is 1:2, right? You can see the ratio, this can be, here not 1:2, we can eliminate. So these two options are there with us. But the question also says that the molecular mass of the compound is 60. But if I add these three, okay, I'll get 30. But if I add this, I'll get 60. So that is why the correct answer is option number B here. Okay. So yes, this is a homework question now. This is a little tough question, I'll say. So I've given you for homework 2020 last year question. So please try this question. A gas mixture contains 25% of helium and 75% of CH4 by volume at a given temperature and pressure. The percentage by mass of methane in the mixture is approximately. So here you have to remember it is 273 Kelvin and 1 atm pressure. That means you can use this formula, that is 1 mole is equal to 22.7 liter. Okay, this relation you can use. So try this question. In the next class I'll be solving it. Okay, so yes students, that's all in this class, and I hope you have learned these concepts and enjoyed the class. Thank you for watching, and please subscribe the channel and see you soon in the next class.